What does it mean to be orthogonal or orthonormal? To get a better understanding of the concept, let's take a look at two dimensions. Here we have our 2D coordinate plane. In 2 or 3 dimensions, a quick 5-second explanation can be orthogonal is equivalent to perpendicular. Let's take a look at two vectors here, v and w. Are these two vectors perpendicular? Obviously not. It follows then that they are not orthogonal either. Let's move w up some here. Here we can see that a 90-degree or right angle forms between v and w. In this case, v and w are perpendicular. From here you can deduce that v and w are orthogonal. This might not be a complete picture though, so let's take a look at the standard basis for R2, E1 and E2. I believe it might help to look at these vectors as column vectors, so E1 would be written like this and E2 like this. Now, the actual formal definition of two vectors being orthogonal is if their dot product is equal to 0. Here we have our dot product formula, simply the sum of the products of the ith component of each vector. So, for the case of the vector 1, 2, and 3, 4, their dot product would be 1 times 3 plus 2 times 4, or 11. There is a better dot product formula to visualize orthogonality, and that is this one involving norms and the cosine of the angle between the two vectors. In case you aren't already familiar, the norm of a vector is simply the square root of the sum of the squared entries of that vector. So for E1, that would just be the square root of 1 squared plus 0 squared, or 1. The same goes for E2. This ends up simply being the square root of 0 squared plus 1 squared, or also 1. But remember, these vectors are orthogonal, and that comes from this cosine element. If we look at the angle between these two vectors, we can see that there is a 90-degree angle between them. You might recall that 90 degrees is equal to pi over 2 radians. Note that the cosine of pi over 2 is equal to 0. Remember, the norms of each vector are both 1. With two norms of 1 and the cosine of pi over 2 being 0, our dot product becomes 1 times 0, or just 0. The last piece to understand is orthonormality, and that only comes with the added condition of a vector being normal. A vector being normal simply means that its norm is equal to 1. The basic idea of an orthonormal list is a list of vectors that are orthogonal to each other and that each have a norm, or length, in 2 or 3 dimensions equal to 1. Mathematically, a list of vectors is an orthogonal list if the dot product of each vector against every other vector in that list is 0, and the normal part of orthonormal comes from when each of these vectors has a norm of 1. An orthonormal basis is an orthonormal list that forms a basis for some vector space. This should make sense intuitively, even if the terminology is strange and unfamiliar. But what is a basis? We'll touch on that in the next video.